the tan trigonometric ratio. What are the primary trigonometric ratios? There are three primary trigonometric ratios. These ratios represent relationships between the sides of a triangle and their corresponding angles. In this lesson, you will focus on the tan primary trigonometric ratio. Naming the triangles. Let's start by looking how to name the right-angled triangle. Draw a sketch for the triangle ABC and label each side. Follow the steps given in the next slide. Steps. Number 1. Draw a right-angled triangle. First, label the corners. The top corner we're going to label vertex A. Label the right-angled corner B. The right-angled corner is marked by a little square box. Label the bottom right corner C. Now, label the sides. When labeling the sides, you are going to use the same letter as the opposite corner, but you are going to write it in lowercase. Let's take a look. Label the side opposite corner B, little b. Draw the arrow across, label it B. Now, label the side opposite corner A, little a. Draw the arrow across and label it A. And finally, label the side opposite corner C, little c. Draw the arrow across, label it little c. Identifying the reference angle. Steps. The next step is to determine which angle is the reference angle. The reference angle is the vertex or the corner point that is used in the question. You will either be finding the tan from the angle or you'll actually be finding the angle itself. For example, if the question asks to find the tan ratio of angle A is the reference angle. Identifying the reference angle. In the previous slide, we determined that angle A is the reference angle. We will show this by putting a line to represent the angle and labeling it the reference angle. What sides are needed for the tan trigonometric ratio? The trigonometric ratio is defined as being opposite over adjacent. So if angle A is the reference angle, the opposite side is across from the reference angle. We will label that little a, and adjacent is the side between the reference angle and the right angle. So it's beside the reference angle. This is shown in our diagram as value C. Now, let's keep in mind that tan theta is opposite over adjacent. You need to remember this. It's an important formula. Remember as well that angle A is the reference angle. The opposite side is across from angle A. The adjacent side is next to angle A, between angle A and angle B. Got that? Let's try another question. For this, we are going to use triangle MNL. And remember, the tan of an angle is equal to opposite divided by adjacent. Here is the sample question. For the given triangle, MNL, what sides are used to determine the tan of angle L? The solution. Label each side with the small letter of each opposite angle. We will label side L. We will label side M. And we will label side N. Now, label the reference angle. Since you're asked to find the tan value of angle L is the reference angle. Label L so we don't forget that this is our reference angle. Now, continuing with the solution for the triangle, identify the side opposite, and remember, opposite means across from the reference angle, angle L. Draw a cross and label it. Identify the side adjacent or beside the reference angle L. Draw the arrow and label it. Now, we've got the diagram. We know the opposite side is L. We know the adjacent side is M. So the tan of angle L, which is opposite over adjacent, is equal to L over M. Now that we know what the tan value is, how do we find its value on the calculator? For this example, I'm going to use a Texas Instrument TI-83. The tan value of an angle is a decimal value. Here's a sample problem to help us know how to use our calculator. What is the tan value of 54 degrees? Here are the steps that you need to follow. Press the tan button on your calculator. Type the angle measure inside the bracket. If necessary, type to close the bracket. It's always a good idea to put the angle value inside brackets. When you press enter, you will see you'll get a value of 1.37638192. Now, you will be asked in a question to round it off. Let's say we want to round this off to 2 decimal places. We look to the third digit. Since it is a 6, we're going to add 1 to the 7 to get 1.38 as our decimal value. Now, find the angle measure of a given decimal tan value. Again, we're going to demonstrate this on a Texas Instrument TI-83. Here is a sample so we have some data to work with. If the tan value of an angle is 1.732, what is the measure of the angle? To find the angle, you will use the inverse tan function on your calculator. Let's take a look how this is done. Press the second key, or on some calculators, it is the shift key. Press the tan key. You will notice that you now have a tan -1 on your calculator screen. Enter the decimal value, 1.732. Close the bracket if necessary. Press enter. Round your answer if you're requiring it. Now, we notice we have 59.999. We would round this off to 60. So our given angle is 60 degrees. Now, sketching a graph given the tan value of an angle as a fraction. Here's an example for us to work with. Sketch triangle ABC in which angle B is 90 degrees and the measure of tan A is 4/3. Remember that tan A is equal to opposite over adjacent. This will help us in the question. Now, let's analyze the data or find out what we really know. Since tan A is 4/3 and tan A is opposite over adjacent, the measure of side A, opposite, must be 4, and the measure of side adjacent to angle A is 3. And now, continuing on, for the analysis of the data, we can find the length of the hypotenuse using the Pythagorean theorem. The hypotenuse squared is equal to the opposite side squared plus the adjacent side squared. This would mean that b squared is equal to 4 squared plus 3 squared. If we do the arithmetic calculation, b is equal to the square root of 16 plus 9, which is equal to the square root of 25, which is equal to 5. Now, we can draw the sketch. Draw the right-angled triangle, label the corners, label the opposite side, and write its measure of 4. Now remember, it was opposite angle A. Label the adjacent side, write its measure of 3, and the hypotenuse measure of 5. Wow, we did it. Now, using tan, let's take a look at how to find values in a triangle. In triangle EDF, calculate the length of DF for a value of angle E equal to 60 degrees, and the length of side DE is 40 centimeters. Express your answer in 2 decimal places. Let's think about this. Here is the diagram sketch. Angle D is our 90 degrees, so we have EDF. Angle E we know is 60 degrees, so we need to label that. Inside DE, we were asked to label it as DE equal to 40 centimeters. Now we're asked to find the length of side DF, which is still part of our right angle triangle. But what else do we know? We know that angle E is the reference angle. Perfect. We label the opposite side of angle E. Opposite. Oh, it's DF. You will need to find the length of DF, which is the opposite side. But how do you do that? So, we know that the tan of E is opposite over adjacent. We know the degree measure of E is 60 degrees. We can substitute that into the equation. We know that opposite, we're using the name DF to identify it. We know the adjacent side is 40, so we can substitute that into the equation. Now we're going to cross multiply. We will get that DF is equal to the tan of 60 degrees times 40. Now it's time to use your calculator. DF is 69.28 expressed to 2 decimal places. Well done. Now it's time to take the quiz. Remember to come back to this video if you cannot answer a question during the quiz and need some support, or use this while you're answering the project. It will be a big help to you. Good luck.